Let's move on to geometry, lesson 12.2b, solving right triangles. So in the last couple of lessons, we've solved for degrees in triangles using trig ratios and using our calculators. We've also used the Pythagorean theorem and the sum of the angles of a triangle to solve for unknown values. We were solving for ratios and angle measures in these problems. If the ratios are already known or measures of angles are known, we can use a different procedure. What we can use is the inverse of the trig ratios. So, if you have sine angle A equals x, then the measure of that angle, the measure of angle A, actually equals sine -1 and x. So what this is essentially moving the sine A over to the other side of the equation. When you do that, you multiply by -1. You may not remember that, but that's one of the first steps you learn in balancing equations in algebra. The same goes for cosine A and tan A. So we'll have the inverse cosine times x and the inverse tan times x. And with numerical values, as an example, if sine 60 degrees equals square root of 3 over 2, and let's look at the example. Here's our 60-degree angle. It's part of a 30, 60, 90 triangle, so we have our numerical values, 1 square root of 3 over 2. If the sine of 60 equals square root of 3 over 2, that's opposite over hypotenuse, then if you're solving for sine or inverse sine, square root of 3 over 2, that will equal 60 degrees. So in these problems, you'll have the ratio available, but you won't have the degrees of the angle available. In our previous problems, we had the angle available and we solved for the ratio. The angle for a given value of the sine is called the inverse sine, or way back they used to call it arcsine. Inverse sine is symbolized by using this -1 superscript, just like you would if you're saying a squared or b squared, and it'll be sine -1, or they also call it arcsine x. Cosine would be arc cosine x, and tan would be arctan x. So let's take a look at example 3 from the text. We have a right triangle. It has a short leg of 3 feet. It has a hypotenuse of 5 feet, and we don't know what the side length is for the long leg, which is AC. It says find the measure of angle A. So let me go ahead and draw this in. And we'll find the measure of angle A. It says write the trig ratio that relates the known sides, and in this case for angle A, it will be the opposite over the hypotenuse, which we know is sine. So sine A will equal 3 over 5. You check your calculator and make sure it's on degree mode, and then you go ahead and enter this formula. If you're using a TI, you'll enter second sine, and it'll show you some parentheses, and then you'll enter 3 divided by 5 within the parentheses to get your answer. Or if you're using the TI from the class, you'll divide 3 by 5 and then push second sine. And you will get an answer in degrees. The answer should be approximately 36.9. Let's look at example 4, and I'm going to go ahead and zoom this a little bit. So in example 4, we're going to solve for all the unknowns in triangle ABC, which when we're solving for our triangles, our right triangles, we need all of the unknowns. That means all 3 angles and all 3 sides. So we begin with information that we know. So we're going to find angle A, and you could actually start with angle B also, it wouldn't matter. But angle A, and we see that angle A has an adjacent and an opposite, so opposite over adjacent will be tan, so it would be tan 17 over 11. Now we go ahead and use the equation we just learned where we're going to solve for our inverse tan, and that will make the measure of angle A equal tan, or inverse tan, 17 over 11, which will be approximately 57.1. So that's exactly like we did in the other example, the last example, example 3. Now we can solve for angle B in a couple different ways. Let's see if I can get this in here, 57.1. Now angle B you can solve by using the sum of the angles in a triangle, and with that you could go 90 minus 57.1 equals 32.9, or if you really like your calculator, you could go ahead and solve angle B exactly like you solved angle A. Because with angle B here, you can see that you have opposite over adjacent, which is tan, and you could do the same. It would just be measure of angle B equals tan, inverse tan 11 over 17, and that comes out to 32.9. And the last thing we need to solve for is AB. So the length AB is the hypotenuse, so 11 squared plus 17 squared equals C squared. C would equal 11 squared plus 17 squared, taking their square root. 11 squared is 121, and 17 squared, let me look it up, 17 squared is 289. That's 410, and if you take the square root of 410, you get approximately 20.2 inches. So this will be side C, and we'll fill that in, 20.2. And there you have all of your unknowns. Be sure that when you're working these problems that you write down what you're solving for, and that's exactly what they've done here in this problem. They solved for angle A, they solved for angle B, and they solved for side C. And you may be looking at this and thinking, wait, there's no C on there. Well, remember with our triangles, our right triangles, if this is large angle C, this is small side C. And if this was B, this would be small b, and if that were A, this would be small a. Okay? Alright, so you'll find, and let me zoom out, that your homework uses this same equations over and over. You're doing numbers 16 through 25, and here's an example of a problem. Homework problem 16. Let's take a look at the triangle. We have triangle XZY or XYZ, and we have side lengths of 12 for the short leg, 15 for the long leg, and we do not know what the hypotenuse is, And we have no angles here except for our 90-degree angle. What we do have is our first ratio. So we can solve for angle Z. And angle Z has opposite over adjacent, sorry, and that is 15 over 12. So then we now go to the second part of the equation that we're going to use, and we say the measure of angle Z equals second tan or inverse tan 15 over 12, and that will be 51.3 degrees. And now we have, once again, two ways to do the measure of angle X. You can subtract 51.3 from 90, and that will give you 38.7. Or you can also solve it using your trig ratios, because you have opposite over adjacent in this triangle also, so you could use the inverse of tan to solve and you'll get the same answer. What we're left with now is the side xz, which is also little y or small y, and we go ahead and use the p theorem for this. Y squared equals 12 squared plus 15 squared, which is 144 plus 225, which equals 369, and y will equal the square root of 369, which is about 19.2 feet. So you're going to solve the triangle, and in these problems you'll round to the nearest tenth. Last demo problem will be number 22, worked exactly the same way as the example 16. So we have a triangle, and this triangle should look familiar. This is the basic triangle we use for our formula. They tell us, though, about values that were given. So side A equals 15, and side C equals 34. So if we're looking at angle A, we have the opposite and we have the opposite and the hypotenuse that we have values for. So we're going to use sine, and that'll be 15 over 34. Now we go to the measure of angle A, which will be inverse sine 15 over 34, which is approximately 26.2. So this will be 26.2. And you can use inverse sine also for the measure of angle B, or you can subtract from 90 degrees and you will get 63.8. This leaves us with our side to solve, and this side is a hypotenuse, so the hypotenuse equals both of the sides added together. So 34 squared equals b squared plus 15 squared. B equals the square root of 931, which is approximately 30.5. And when you solve for these problems, they should look reasonable to you. A right triangle will have ratios that look reasonable. This length 15, oh, I'm sorry, I wrote that in the wrong spot. 30.5, let's correct that. And when you solve for these, you can see that this visually, the short leg is about half of the long leg, and there you have it. 15 is half of 30, and the hypotenuse will always be the longest leg. If your longest leg ends up being not the hypotenuse, but one of these side legs, then something's wrong in your equation. So there it is. I hope this helped. Be sure to contact me if you have any difficulty. And We'll be moving on to 12.3 soon. Talk to you later.